Hello. In this video, we're going to look to find the derivative function for f of x equals the square root of 4x minus 1. When we look to find the derivative function, we set this up exactly the same way as any other derivative. F of x plus h minus f of x all over h. Right? We're taking the limit as h goes to 0 of our difference quotient. In this case, I'm asking, what do I do with this x plus h in here? And again, what we do is we replace that instance of x with the parentheses x plus h minus f of x, which is 4x minus 1, all over h. And if we remember how to solve these difference quotient problems, we're going to want to use the conjugate. But before we use that, we really want to try and simplify what's inside that first parentheses. It will make our conjugate a little bit easier to find. Let's see, I just distribute that 4, and I get 4x plus 4h minus 1 minus root 4x minus 1 all over h. And again, now I'm going to look to multiply by that conjugate. The exact same expression as my numerator, but with a plus instead, 4x plus 4x minus 1. Over the exact same expression, 4x plus 4h minus 1 plus root 4x minus 1. Right. We continue writing the limit as h goes to 0. That denominator will keep unexpanded, so h times this big quantity, 4h minus 1, plus square root of 4x minus 1. And when I look to FOIL this numerator, I know I'm always going to get the same expression. That first quantity squared minus that second quantity, 4x minus 1 squared. Every time I FOIL conjugates, I will get the exact same type of expression. This first quantity squared minus that second quantity squared. And when I look to simplify this numerator, I see that I'm squaring a square root. So all I'm left with is what's inside of that square root, right? The square and the square roots will cancel. Minus, all I'm left with is that 4x minus 1. All over that unsimplified kind of longer denominator, plus 4h minus 1 plus root 4x minus 1. I continue writing the limit as h goes to 0, and I see that these parentheses were ultimately unnecessary, so I can drop them. But remembering I have this negative, so I want to distribute. 4x plus 4h minus 1 plus root 4x minus 1. I'll look to see what cancels in my numerator. These 4x's will cancel, and these 1's will cancel. I'm left with 4h all over h root 4x plus 4h minus 1. Sorry, that's a minus 1. Plus root 4x minus 1. Finally, these h's cancel, right? That's what I'm looking for when I'm simplifying the difference quotient. When do these h's cancel? And I have 4 over the square root of 4x plus 4h minus 1 plus root 4x minus 1. And so finally, now that I've canceled my h there, I can actually find the limit and plug in 0 for h. And if I do that, I'm left with 4 over root 4x minus 1 plus root 4x minus 1. And I'd say, well, how many 4x's minus 1's do I have in that denominator? I have 2 4x minus 1's. And this 4 and this 2 can reduce to a 2 over root 4x minus 1. And that function is the derivative of my original function.